Hello and welcome back. So, I'd like to mention that I know, and it is very deliberate on my side, that I have not attempted to explain these APIs like GPIO is ready DT, GPIO pin configure DT. The reason why I haven't done that yet is so that we can keep laser focus on the particular technique that I want to teach you, which is device trees. There will be a dedicated section on knowing everything about GPIOs, and at that point, I will spend time to explain to you what a GPIO DT spec and what all these functions do. So please ignore them for now and keep your focus on the device tree. Once you have an understanding of that, it is easier for you to do everything else in Zephyr. So back to the device tree source for STM32F4 Discovery, which is the board that I'm using. You can see that up here, there are include statements, right? Which is similar to how we also include header files in our C code. And so this is also something that they borrowed from C, right? Now, it affirms the hierarchical nature of the device tree technique. So you can see that at this point, STM32F4 Discovery DTS, this is the device tree for a board. And like I explained in the previous video, a board basically takes the system on chip, which in this case is the STM32F407VG chip, and then it adds other things to form the board. So on the board, I can see LEDs, I can see a microphone, I can see speaker out, and there are other sensors on the board, right? This is what development kits are for, just to make it easier for you to get your hands dirty with a particular system on chip. So you can see that in the definition, that hierarchical nature is also encapsulated. So it is saying that it depends on some other definition, which is STM32F407XG, which is the SOC or the system on chip that has been used to build this particular board. So then I can navigate to that file. And the difference between the .dts and the .dtsi here, DTS basically means device tree source. It is the human readable form of the hardware description that we want the firmware to see. And a DTSI is basically device tree source include. So these are meant to be included in other files. And you can see that in the STM32F407.DTSI, it also includes STM32F405.DTSI, which is here. Now, if you have opened the data sheet for this microcontroller, the STM32F407, you can see that ST Microelectronics actually combined the information for 407 and 405 in the same datasheet file or book, because the system on chip, for 407 and 405 are very similar, right? So if we look at it from the SOC level, you can see that there's a root here, like I said, which is the parent, and then there is a node. So this node is the system on chip. And then it comes to define the peripherals and even the addresses with which we can access those peripherals. So if I am doing bare metal, which I can do in Zephyr as well, then I already know that to access this particular peripheral, the address I need is 40028000. And then there are properties. So like I said, properties are just key value pairs. And you can see that this property here, reg, is actually giving us the base address and also the offsets into that address, which will help us to access this particular peripheral. And then we have the Ethernet here, and then it has a label called MAC. And then there are more properties, right? So this is defining everything that is needed, that is available on the SOC. You can see that it also includes 405. So there should be more details when I come into the 405, and you can see it here. Here, there are definitions for all the UART, their addresses, the offsets, and look at it, timers and counters. So this is how I want you to handle device tree source, or that technique of device tree source, in your journey of learning Zephyr. It doesn't make sense to spend a whole video teaching you everything there is to know about device tree source. I just want you to have an idea that this is what is going on behind the scenes. When we start using the peripherals on the board, then we can go into the details of what you expect to see in this device tree source, and how you can also modify them to do things that you want them to do. So the takeaway from the last video and this video is that there is a device tree source, is a technique by which hardware is described to your firmware, period. And then the next thing you ought to take away from that is there are macros available that helps us to be able to access the nodes in the device tree source in our code. So for example, DT alias here helps us to access a node using the alias, right? So if I go to this and I search for LED3, I should see it under the alias section. Look at it. And so when I come here and I write DT alias LED3, some magic is happening behind the scenes that is actually helping me to control the blue LED on the board. And this is only because I am targeting a board. If I build a custom hardware, then I am going to let the build system work with something that includes only STM32F07.DTSI. And then I will define nodes for other hardware, sensors, or peripherals that I add to my custom board. And to do that, there is a technique called Devicetree overlays. So you create a file which follows a particular naming convention, which I will tell you about. And then the extension is .overlay. So when the build system sees any .overlay file in the root of your project, is going to include that in the build system, and that is how you overwrite the definition. So I totally agree that device tree, I mean, understanding the concept of device tree can take a bit of time. That is why I'm also encouraging you that even if you have not understood it correctly, just bear with me. In the subsequent videos, we are going to start talking about GPIOs, and there we will get a bit deeper. And then as we begin to talk about other peripherals, we will also dive deeper into their device tree definitions, and at that point everything will come together for you to have a better understanding. So thank you very much for watching this, and I will see you in the next video.